So an ORM stands for Object Relational Mapping. This just means that we map SQL objects, which are relational, and you have, foreign keys and primary keys to actual objects in code. So that way we can more easily both read and view, respond in objects, and also manipulate them. So that way you can set properties and say like save changes instead of needing to think about, okay, how do I do an update statement in SQL Server? Oh, this is a Postgres table. How do I do an update statement in Postgres? ORM abstracts all of that. It's really nice, but I don't think they're perfect. And here we just have a little bit of a sample of here's what a user demo table would look like, and here's what the ORM entity framework would let us operate on. So this isn't all the like boilerplate code, but this is the object that you would actually use when you're interacting with the database. And so, yeah, they make it really easy to read, document, and actually talk about our database objects. That's where ORMs are like the shining beacon in the sky. I don't think anyone's going to fault them for this. It's so much better to actually deal with these objects. We can make link queries on top of them instead of having to do nitty-gritty SQL queries. Like I had to look up the like statement. I didn't know if it was the same in MS SQL and Postgres, and they seem to be the same thing. I'm sure you guys can tell me how I'm wrong and that they're not actually the same query, but we'll leave that as an exercise for the reader in the later arguments. So this is actually a live query from one of our systems that I work at my job. You can see that that's not exactly the most readable thing in the world. If we have an ORM object, we can actually just operate on top of the object instead of needing to see all of the SQL. So that's from one route endpoint. So at an API at work, generates all of those statements. It was difficult to get them into a screenshot, so you'll have to forgive me for how small it is. Another thing that ORMs really protect you against is SQL injection. That's a big problem for anyone who's developed an external API. You need to clean your inputs, you need to sanitize, and you need to parameterize everything. ORMs just kind of do that as long as you're making sure you're following their the flavor of the month or the how the ORM wants you to do that. And they all vary differently. But in any framework, I actually will be posting a list of resources I use to kind of go over this talk. And Entity Framework is one of the better ones. You can do cleaned inputs, and you can even do raw parameterized queries. So if you do have to dip down into the raw SQL, whether you need to tell your query planner, like, hey, query planner, don't use this index or don't use this, I want you to do this, you can do that in Entity Framework, which is a key mark of a very good ORM. Bad ORMs do not let you do raw SQL, and that's a problem. Also, as I was building this talk and doing some code samples, I noticed IntelliSense is the best. Like Python doesn't have anything on IntelliSense. So you guys definitely did something right by picking C# as your career language. So you can always have this beautiful autocomplete. Like sometimes I just hit dot and I don't even know what I'm looking for. And I just kind of see them all. And I remember, oh yeah, I'm trying to do XYZ. So that was really good. Another thing is the type safety. This provides twofold things. It's really for the documentation as well as for making it easier for your juniors, your mid-levels, and even senior developers. Because seniors, you have like your hands in every single thing, and it's difficult to know what you need to be working on at the same time. So here's the ugly, and I kind of alluded to this at one of my earlier comments, is that the code first is something that a lot of people like. Here's my first hot take. Code first is not the way to go. And the big reason is because nothing else integrates to it. And you might say, well, Joel, integrating to a code first database is an anti-pattern. You should have something sending that out to a data lake or something like that. And you're right. You shouldn't be directly reading and writing to a database that you've built in any other application. You should always be having data pipelines to move that data to another spot where a new owner can operate on that data. That's a good pattern. The rub is that the world is not perfect. That we all work at companies with many teams, and sometimes you need to just connect to the database to get your job done. Code first databases give you huge dangers in your migration strategies, because if I need to migrate data that takes more than a few milliseconds, I need to ensure that I can do that without downtiming my production environment. And if I have to downtime my production environment in order to migrate code, all database changes are going to be very fragile. We don't want that. There's a good article that talks about doing zero downtime database deployments that I'll send to you all. I definitely recommend that, whether or not you agree or disagree with me. And I would really love if someone who wants to fight for code first could jump into Twitch chat because I think these are great. Um, the other thing is that query planners still run the world at your database level. So that I don't know if anyone's run into this before, but if you've built a lot of indexes on a database and you have a query with many clauses, you'll run into a fact where sometimes your query will use the indexes and sometimes it'll do a sequential scan. And you may actually want the sequential scan. If you've already done something, uh, let's say you have a gist index or a gen index, something that is not a simple text string, that it can't be just a B tree where you can do like what's the word I'm looking for? Binary search. So you can't necessarily binary search on it. You need to have multiple passes over an index. A sequential scan might be faster because you might be able to do it in one single pass of the database table. Obviously, this falls apart if you have billions of rows, but if you have billions of rows, you shouldn't be listening to me talk anyway. You probably should be listening to someone smarter than me. But for millions of rows tables, sequential scans can actually be faster than many index lookups if those index lookups have to be done repeatedly. The other problem I find is that they tightly couple a lot of our application logic to the stored data. This isn't great because now, again, to your migration strategies, if you need to migrate from database A or from table A to table B, you now have to change the code in the database at the same time. You can't create the new data, migrate the data without the code knowing about it yet, then ensure a code over where your code now knows about it, knows about both objects, and then you deprecate one and now you're only on the single table, right? So this is the kind of like a four pass approach that the article discusses for zero downtime databases. And when you're using ORMs, it's a little bit touch and go because if you ever change the type of a column, if you ever change the name of a column, especially if you ever change a foreign key or constraint relationship, it gets very tricky. And then also some ORMs, again, not most, but some. I've seen this a lot in the JavaScript world. If you guys are looking at some of the ORMs, they make it really hard to dip down to raw SQL. And you might say, well, the whole point of an ORM is so I don't have to write SQL. But again, this is the real world. The real world is messy. A lot of times, and in fact, every place I've ever worked has always had a use case for, okay, let's dip down into the raw SQL. Maybe Entity Framework doesn't support this type of index lookup. Maybe we need to do something really dirty and treat strings as JSON, and then we need to operate on that JSON. And so we can't do that directly in the ORM. Maybe we have some stored procedures that we don't want our ORM to know about. There's lots of things like that that feel a little dirty, but we still have to do them. And so this is a little example of how to actually do raw SQL and Entity Framework. One thing that's important to note, you'll see this at P1 in the screenshot. That's a parameterized query, which is awesome. I will say most ORMs don't do this, so mad props to Entity Framework for having parameterized queries in raw SQL. All right, this is my favorite story that I get to share with you all. This is about Prisma, which is a TypeScript and JavaScript GraphQL ORM. Really powerful. A lot of smart people built Prisma. I have a bone to pick with Prisma, and here's why. So I have several things in this slide. Just to break it down a little bit, the key problem is we had an insert statement that needed to insert a float. So we had a float, double precision in our database. We needed to insert a value to that. And it worked great if it was this 1.234 number. But if you sent 1, like 1.0, something fell apart. And there's really two big reasons for that. And that's because there's a Rust processor in Prisma that is actually talking to the database, not the JavaScript layer that you're interacting with. And part of this is because people are smarter than me and they built this really advanced system to do byte streams of queries and actually operate on the bytes at the database level. And all the Rust code handles this. The problem was in this 1. JavaScript doesn't know what 1.0 is. It just sends 1, right? There's no such thing as a decimal or integer in JavaScript. It's just a number. And so when that number was sent to Rust, Rust has a difference between an integer and a decimal. It read that 1 and said, you're trying to set an integer value. So the part of the Rust code that received the value and the part of the Rust code that talked to the actual database didn't communicate on this. So Rust receives a 1, says, I will encode this as a binary integer, sends it to the database code. The database code says, I need to prepare an insert statement with this parameterized value into this column of this name. Well, that column's a double, and that binary value it's about to send is an integer. So you see this little sign bit exponent in mantissa. This is how floating and doubles are represented in code. This means it was sending the smallest non-zero positive integer to our database, which is about 4.9 times 10 to the minus 324. You could see how this might be a problem if we go to read that value where we thought we had just saved 1, and now we have some number that is so close to 0, most libraries will treat this as 0. In fact, Python will give you a divide by 0 exception if you have this in the denominator of your divisor. So don't do this. This is a huge problem. Prisma, I think, has fixed this now in their version. Thankfully, we at work have migrated away from it. So no longer our issue to deal with, but this was a huge nightmare in our production system because who thinks to check if their ORM is actually sending values to the database right? I never thought to check that, and this is what really burned me from ORMs. Here's one for all of the Entity Framework and C# guys. I actually don't know the answer to this question, so I would love it if you could tell me. This is a way to do a direct join. So that way, let's say maybe these weren't foreign key relationships the Entity Framework knew about, so you couldn't just say .include. And this is a really nice syntax. And when I worked in C# in 2016, they didn't have this as beautiful of a link syntax. I felt like I had to do it with unions and withins, and that one wasn't as pretty. I didn't enjoy that. So here is what we're doing is we're joining up authors, author biographies, and books. And then we create essentially a big list that has all of that information. And you can see in that second link expression, we actually are grabbing all of the different things. The problem here is what happens, let's say an author has an awards. And after this, I do a .include awards. And that is a foreign key relationship. What will that actually do to our database? Will it do a third join under the hood? Will it do a subquery to fetch all of that where we have an n+1 number of results and number of queries as we iterate through our authors? We don't actually know until we try it and run the SQL. So this is where I think unless you know what you're doing, an ORM can really hide a lot of this. If you're just typing over these database objects and you think they're objects in code, there's actually a lot of work that database is having to do by fetching by foreign key, deciding whether or not to do a subquery or a join. In fact, I believe Entity Framework always tries to do subqueries. My main point is that because the ORM makes it so easy to operate on objects, you don't necessarily know what those objects, what the database and ORM had to do to give you those objects in code, which can be good and bad. The bad can be the performance trade-offs. The good can be, this is really easy code to look at. For me to write out a database inner join and do all of that is fine. It would look very similar to this, but now I don't have the ability to say, oh, I want to include their awards or their favorites or their prices, right? Because right here, I don't have a price for any of these books. I just have book titles. I don't have a year it was written. I don't have any other metadata. And so it makes it easy to expand your queries in Entity Framework, but it does make it a little scarier because you can do a .include or a dot property name, and all of a sudden your query execution goes to poop. So you don't want that. So, but thank you guys for